There's a diagonal product property of box multiplication, and we can use this diagonal product property where the diagonal product of a box multiplication is equal to each other, and we can use this to help us factor really hard quadratics when we have a leading coefficient of some number, or ax squared when we generalize it. So if I were to write this out, I know that this has to be 12x squared, and this has to work out to negative 75. And the key to factoring a quadratic is always in how do we split up the middle. Now, it's really hard to tell how we split up the middle here when we look at it in this way. However, if we take a look at the diagonal product of this, I get 12 times 75. So this works out to be, what's that going to be, 900. Or negative 900 x squared. And we know that this diagonal product across the other diagonal must also multiply to 900. However, we know it adds negative 900, and we know it adds to 80. Well, what two numbers multiply to 900 and add to positive 80? Or sorry, multiply to negative 900 and add to positive 80. It's going to be 90x and negative 10x. And that diagonal product is going to be equal to what we're looking for, and it allows us to split up that 80 in the middle. And that's the key to factoring. So to get the binomial parts for this, we just need to take out the common factor this way. In this case, it's going to be 6x. The common factor this way is going to be 5, so it's going to be negative 5 because it's negatives on both of those terms. So this was negative 75. And then we can take out the common factor vertically. That's going to be 2x. The common factor this way is going to be 15, so it's going to be 2x plus 15. So this factors into 6x minus 5 and 2x plus 15. Okay, so this diagonal product property can then be used to help us factor the really hard quadratics with an ax squared.